Hello everyone, my name is Arif Aiman, and today I will be explaining the bipolar junction transistor, or BJT for short. BJT is an essential component in modern electronics. BJT are widely used in circuit for two primary purposes: amplification and switching. These functions make them an integral part of everything from small audio device to complex computer processor and power electronics. Before transistors were invented, vacuum tubes were used for this function, but they were bulky, consumed a lot of power, and were not very reliable. With the invention of transistor, electronic devices became smaller, more energy efficient, and more durable. BJT play a significant role in the rapid evolution of electronic technology, and even today they remain widely used despite the rise of MOSFET and other semiconductor devices. The objective of this practical 3 is to investigate 3 key aspects of BJT: BJT terminal and their function, the two main types of BJT, and the material used to manufacture BJT. BJT terminal have 3: base, collector, and emitter, and there are 2 types of BJT: NPN and PNP transistor. The material used to manufacture BJT are also different. There is silicon and germanium BJT. By the end of this video, we will have a clear understanding of BJT and their importance in electronics. So let's dive into the first topic: BJT terminal and their function. A bipolar junction transistor consists of 3 terminals, each playing a crucial role in controlling current flow. These terminals are the base, collector, and emitter. Understanding how each of these functions is key to using BJT effectively in electronic circuit. Let's break down of each terminal. First, let's start with the base. The base is the control terminal of the transistor. It is the thinnest and lightly doped region, meaning it has fewer charge carrier compared to the other region. A small current applied to the base control a much larger current flowing between the controller and emitter. Think of it like a gate or valve. A small action at the base allows a much larger flow of current through the transistor. Now let's talk about the collector. The collector is the largest terminal in the transistor and is responsible for collecting charge carrier. It is the main current input in most transistor applications. The collector is moderately doped and has a larger area, allowing it to handle higher current. It is usually connected to the positive voltage in an NPN transistor and the negative voltage in a PNP transistor. Now let's talk about the emitter. The emitter job is to emit charge carrier into the base. It is heavily doped to ensure a large number of charge carrier are available. The emitter is responsible for the majority of the transistor current flow. In an NPN transistor, the emitter is negative, while in a PNP transistor, it is positive. To better visualize how this terminal interact, let's look at a simple diagram showing the current flow in NPN and PNP transistor. Notice that in an NPN transistor, current flow from the collector to the emitter, whereas in a PNP transistor, it flow in the opposite direction. This difference is important for understanding how different transistor circuit works. Transistor BJT.
Terbalikan pro.
Sekejap.
Okey dah. Cucuk.
Terminal merah ini infinity. Terminal merah dekat nombor 2 ini infinity. Merah dekat terminal 3 ada bacaan, sini ada bacaan. So maksudnya terminal 3 ni base. Now that we understand the terminal, let's move on to the main type of BJT. NPN and PNP transistor. This type differs in terms of current flow, direction and biasing condition. In NPN transistor, the majority charge carriers are electron. When a small positive voltage is applied to the base, it allows a much larger current to flow from the collector to the emitter. The circuit is considered active when the base is given a small positive voltage relative to the emitter. NPN transistors are the most common type because electrons move faster than holes, making them more efficient. Now let's talk about the PNP transistor. In a PNP transistor, the majority charge carriers are hole instead of electron. The current flows in the opposite direction from emitter to collector. To turn on a PNP transistor, the base must be more negative than the emitter. PNP transistors are often used in complementary circuit alongside NPN transistor. To demonstrate how we can identify an NPN or PNP transistor circuit, we can use a multimeter. By testing the resistance between terminals, we can determine the type based on how the current flow. In an NPN transistor, the base emitter junction behave like a diode in forward bias, while in a PNP transistor, the base collector junction does the same. This method is useful in troubleshooting circuit and identifying unknown transistor. I will provide a video after this.
Okay dah.
Okay, kalau nak tahu NPN atau PNP, probe tengok probe positif mana. Kalau probe positif merah, dia NPN.
Ya. Okay dah. Okay. Guna 10k ohm.
10k ohm.
Okay dah.
Okay, ni NPN type. So negatif dekat base terminal,
Okay.
positif 1. Okay, macam ada terminal 2. Okay, terminal 2 higher. So terminal 2 collector, terminal 1 lower, emitter.
Okay dah.
Now let us continue and discuss the material used to manufacture BJT. The two primary materials used are silicon and germanium, Si and Ge. Both are semiconductor, meaning they have electrical property between those of a conductor and an insulator. Why is silicon more commonly used? Silicon is the most widely used semiconductor material in modern transistor because it has a higher thermal stability, meaning it can operate at a higher temperature without breaking down, and it also has a higher band gap energy, making it less prone to leakage and current. The third is it is more abundant and cheaper to produce compared to germanium. Lastly, almost all modern electronic devices use silicon-based transistor because of this advantage. Now, let's talk about when is germanium is used, because silicon is most commonly used. Germanium transistors were used in early electronic and are still used in some high-speed and specialized circuit because they have a lower voltage drop. This can be useful in specific low power application. It is also better performant in high frequency circuit, although they are more sensitive to temperature change. Despite this advantage, germanium is not as widely used today because it is more expensive and less stable at high temperature compared to silicon.
Okay dah. Ni lampu ni.
Okay, nak tahu silicon atau germanium, red probe dekat emitter, black probe dekat collector. Okay, bacaan dia high, kita bacakan red probe dekat collector, black probe dekat emitter. Okay, bacaan dia high. Kalau dua-dua high, dia silicon. To summarize, we have explored the key aspect of bipolar junction transistor, BJT terminal and function, base, collector and emitter each playing a critical role in controlling current flow. The type of BJT, there are NPN and PNP, differing in current flow direction and biasing condition. The material used, silicon and germanium, with silicon being the preferred choice due to its superior stability and electrical properties. BJTs are fundamental in electronic circuit design, used in amplifier, switches, and many other applications. Understanding how they work allows us to design efficient circuit for various technological advancement. Thank you for watching, and I hope this explanation helped deepen our understanding of bipolar junction terminal. Thank you.